So I want to thank you for inviting me, and I hope this talk gives us an opportunity to discuss potential applications of AI. We are not a university that focuses on agriculture, so we are an engineering stroke applied sciences university in Malawi. So where I am based has changed its name. So originally it was called the Malawi Polytechnic, and this was the college under the main university in Malawi, and is the only college who is specializing in engineering and applied sciences. So I hope there will be some scope for us to discuss some possible applications of AI. What I'm going to show you today might not be applied to agriculture, or is not applied to agriculture, but this is an area of extreme importance, and especially to Malawi. Malawi is a culture, is a country that relies on agriculture. So most of the people in Malawi rely on smallholder farming. So there's a lot of challenges in terms of the food supply. So having said that, I just want to start my talk. So I wanted to share with you what I've learned through my experience in the academia and industry about AI, and how has that formed my approach to research in this area. So I'm not going to say more about me because the dean has nicely introduced me. So I'm a lecturer here in Malawi. I started to work here in 2015 after we relocated to Malawi. Before coming to Malawi, I was working in the industry. So I was working in the asset management side. So I was developing risk allocation and financial models. And here at MUBAS, I teach modules related to data structures and algorithms. So algorithms design, computational intelligence, and AI. I conduct research in natural language processing, health informatics, and computer science. And recently, I set up an AI lab here at the university, which is called Kuyesera AI Lab. Now, Kuyesera is a Chichewa word, which is one of the local languages here, and it means experimenting, or you can maybe translate this as experiential AI. So this takes me a bit back to my early days. So during 1997, 2001, I was a student in computer science in Romania. Now, at that time, computer science was sitting in the mathematics department. So there was a really close relationship between mathematics and computer science. And one of the modules I studied in year 3 was symbolic logic. And this module really attracted my attention. And the two main areas that caught my eye was the use of logic to represent knowledge and reasoning. So I began to think how we people process, represent information or knowledge about the world, and how are we able to reason about it. And then this is what the goal of the computers were. I mean, initially computers were means of computation, so performing fast calculations, fast computations. So initially computers were used for automating tasks that are repetitive and tedious, that humans were prone to making errors. So things like large calculations, statistical calculations. But computers were also, especially AI, deals with computers that are able to do intelligent tasks that we humans are good at. So those tasks sit in the knowledge domain. So machines need to be able to capture and represent knowledge and reason about it. And the other area that caught my eye was what's called the satisfiability problem. Now, this might not be familiar to you, but just to explain quickly. So imagine you have a circuit, just like you have on the right, which has different gates, like OR, NOT, AND gates. And you would be able to write this as a logical expression using AND and ORs. And then you have these variables that you see there, the X1, the X2, the X3, which are inputs. And you get an output. Now, the satisfiability problem is all about how to instantiate or how to give values to the input variables so that you get a desirable output, maybe true. So that it's interesting enough, the satisfiability problem is one of the hardest problems in computer science. And it's considered what's called an MP complete problem, extremely hard, especially when the number of variables or the scale of this expression is extremely huge. Now you can kind of imagine that this circuit that you see here, it's a bit like a reasoning process. So you're saying if X1 or X2 is true and not X3, or I'm not being precise here, but then you will have something happening. And you can replace this X1 and X2 with some knowledge or some information that, it's useful. So these two areas have really caught my attention. And also this idea that some computations are hard for machines. Now, some computations are very easy, but some computations are hard, like the ones I'm explaining here, to do with knowledge and reasoning. So because I enjoyed that course and stimulated my thinking, I chose as my final year project to work on a natural language interface. So this was an interface for booking flights, and the idea was that the interface would be able to give useful answers to the person querying, so providing more information. So, for example, if a flight would not be available in the database, it wouldn't just say no or give no answer, but it will explain that, well, we don't have a flight for this period, but there are these other options for you. So this is the work I chose to do as an undergraduate student in 2001. And I've put a picture on the right just to show, how our computers used to look like, during those times. And I, as a student, in fact, I did not have a personal computer. I managed to borrow one as my, during my final year, so I could do my project. But, computers at that time weren't that available as we have now. And also when it comes to the AI, during that period, the 1990s and the 2000s, AI was really kind of out of limelight. So, the symbolic logic kind of topic wasn't really what people were talking about. And a lot of AI developments were taking place, again, kind of silently. So I'm giving some examples here. 1997, we had the computer Deep Blue, and this was a chess playing program which managed to beat the grandmaster at that time, Garry Kasparov. And then we had developments in speech recognition, which were incorporated in Windows. And MIT was also working on some experimental robotics that could recognize emotion. Now, during that time, AI wasn't receiving a lot of funding. As I said, government funding. It was mainly projects that were taking place by different corporations. Before that, So 1950s, now this is a very large area, so I'm not doing justice to the history of AI during that time. But during 1950s to 1990s, we saw the AI domain flourishing and receiving a lot of funding. And the term artificial intelligence was coined at a summer school in Dartmouth in the US. And at that conference, a program was presented. It was called The Logic Theorist. And this was a program that was mimicking how humans solve problems. And that program caused a lot of enthusiasm and also a lot of discussions around the potential of developing a computer program that can reason and be intelligent just like humans are. And, the definition of intelligence was an area that, people have been working on. What does it mean that the human is intelligent? And what do we mean that a machine is intelligent? Into what direction, the AI idea should take. A lot of things have come out of that, including a lot of interest all across the world. So between 1957 and 1974, AI flourished. This was also coupled with advances in hardware. So storage, computers were becoming more affordable. Memory the memory storage was also better than before. There were advances in algorithms for problem solving. And in the US, the US government had put a lot of funding in AI. In 1980s, following a bit of a slump or disappointment into what AI was actually in a concrete way coming up with in terms of systems, there was a kind of AI reignited. So more people have worked on algorithms. So initially what people were thinking is that there is a limitation in terms of storage, that we are not able to, create true AI or intelligent machines because we are still limited by the hardware. But the AI flourishing period or the golden period of AI showed that there is more to that. It's not just about storage, it's also about algorithms or the reasoning. So following the 1980s, there was an expansion of the algorithmic toolkit that people were developing. Ideas such as deep learning were popularized by researchers, including Geoffrey Hinton, who then joined Google, and he published a paper that explained how deep learning can help machines learn from data and introduce this concept of backpropagation. The other thing to note there that in Japan, the government decided to invest huge amounts of money, I think over $400 million in AI under what was called the fifth generation computer project. And a lot of emphasis in this area was on getting the reasoning right, the algorithms right for advancing in AI. So prior to 2000s or the year 2000s, more or less the emphasis in AI was on symbolic logic as means of representing knowledge and of achieving automated reasoning. And a lot of corporations, I think I was looking at some statistics for you. I didn't put them on the slide, but more than 50%, or it was a high percentage of companies in the developing world who were working on some kind of expert or decision support system in their corporations. So they were very popular. However, very few have really succeeded fully in the tasks that were set, and very few have, survived or have been maintained over the years. So this expert system, what they were doing is that they were using symbolic logic rather than numerical calculations to derive facts or reasoning facts from the data that they had available. So the processing was data-driven, a little bit like what machine learning is today, but the difference is that they relied on a knowledge base that contained these explicit rules or content that represent a specific area of knowledge. And the systems were able to interpret conclusions and provide decisions that were understandable to the user. So the expert systems are still popular today, and they have remained popular over the AI history. But what has changed? Our desktops don't look as bulky as they used to be. And a lot of advances in memory and computation have been removed. I've put that in brackets there because there is still a limitation in terms of access. So, although we do have more powerful computers now, we still can't do a lot of AI models on our personal machines. Access to high computation power is still expensive. But in terms of AI development across the world, or macro AI, if you want to call it, a lot of the limits on and this is where systems like the Google AlphaGo relied on. So they relied on much faster computation to defeat the Go champion in 2016. And 2017, Google came up with a new framework or architecture that is able to do AI type of computation. So ingesting vast amounts of data and making connection between distant data points. And that architecture is called transformers. And OpenAI or GPT type of tools are based on this architecture, the transformer architecture. But looking at this type of advances, it's still pertinent to ask, how close are we to intelligent machine? We have made advances in memory and computation. What's happening on the algorithm side? And this is not that clear cut. Answering this question is not that clear cut because most people forget to talk about the algorithmic limitation. But let's try to think, how close are we to true AI? I'm going to take you back a little bit to answer that question. Again, in the early days of AI, when Alan Turing formulated this test for machine intelligence, and this test came to be known the Turing test. So the experiment was set out in this way, that we have an interrogator, a human, that's player C. And this player C is typing questions or typing some text, communicating via an interface with somebody. Now, the interrogator, player C, doesn't know who they are speaking to. So they can speak to a computer or a human responder who responds to the questions. So the computer responds to the respondent, and it can also ask questions. So the test says that if the interrogator cannot distinguish, cannot tell whether is speaking to a machine or to a human, then the computer has passed the Turing test. Now, when this Turing test was developed, the hope was that the computer can talk about any domain, agriculture, computer science, history, anything you can think of. But very soon, it was becoming obvious that it's very difficult to pass such a test. So there's been narrower domains in which this test was kind of hoped to be surpassed. So maybe the computer should really only answer about agriculture. There should be only questions about agriculture, nothing else. To date, there's been no success in fully passing this test by any machine, although there's been some successes in narrow domains, just like we talked about. What was useful in thinking about this Turing test is that 4 characteristics were formulated. So these are 4 characteristics that a machine needs to have in order to pass this Turing test. And those 4 characteristics are knowledge representation or knowledge engineering. So the ability to represent knowledge internally, automated reasoning, the ability to reason about that knowledge, natural language processing, so this is communication, and in the original Turing test, natural language processing was text-based, but of course, you might think of other forms of language communication, and machine learning. And at that time, machine learning was referring to the general ability of machines to learn or infer or add to their knowledge base new information. And for an extended Turing test, the computer should also have some hardware, so robotics and computer vision. So this criteria is what really is being pursued when it comes to AI in various forms. And we still, today or nowadays, a lot of emphasis is on the last 2. So we have seen a lot of powerful systems that deal with natural language processing and machine learning. And there is less talk about, I'm talking like generally, right, about knowledge representation and automated reasoning. And during the early days, people were asking a lot of deep questions. And I'll give you one example. How does knowledge lead to action? So knowing what you know and, having the ability to ingest and take in all the knowledge in the world, what is that relationship between, knowing and doing? So reasoning, but not just reasoning, but acting on that knowledge. So things are complicated, things are complex, and to some extent, people advance in most of these areas, although some deep questions are still here with us, just like I gave an example of. So in 1973, there was a report in the UK, and this was called the Lighthill report. The Lighthill is the name of the person who did this report. Now, he was not a computer scientist. He was an engineer by profession. But what he did is to look and do an analysis of the type of AI systems that were present at that time. And what he noted in that report is that the AI systems were not truly intelligent. And there was several reasons why he said that. One of them was that, he observed that all the AI methods need or require to have substantial knowledge of the subject matter in order to be useful. But they lacked the ability to automatically acquire that knowledge. So somebody had to not only provide that knowledge, but provide how the knowledge should be represented and how the knowledge should be used. From a truly AI system, you would expect that the system should be able to do that by themselves. Looking at that knowledge, it will automatically know how to represent it and how to use it. And the report is quite detailed. I'm just taking out a few of the things in that report. And the other thing that he noted is that existing AI techniques worked well only in the lab or on small domains. And in his words, they were woefully inadequate in large-scale realistic problems. And here he was giving the example of a kind of engineering system that was using AI to land planes. So he was saying, well, we still rely on radio technology to land planes because they work in the expected conditions better than an AI. Maybe AI can work better in an unpredicted scenario, something you haven't seen before. But if you want something reliable, then you might not deploy, an AI solution in the real world. So this report, as I said, although it wasn't, technical in the sense that, Lighthill wasn't a computer scientist, it really made a lot of impact, and a lot of the funding in the UK dried up for AI systems because of the limitation in terms of practice that were perceived. But where are we today? I mean, this is something I've been, thinking about. So to some extent, we have a macro, I'm not sure if these are the right words there, but we have a macro AI, which is the true AI. So something we want to work off the shelf, maybe an automatic, autonomous, robot who takes in information, makes decisions, represent knowledge. So in effect, has all those characteristics of the Turing test. So this really is not something we have. And a lot of emphasis is on what we call this micro AI or experimental AI. So this is AI that looks to be very useful in smaller or subtle ways to automate tasks, predict some outcomes, classify documents, support humans in various tasks like translation. And typically these modules or these micro AI modules are integrated as a component into a larger system. And this is another way to think about that, that there is a symbolic AI versus a generative AI. And I think this word generative is something that you have become familiar with. Other people also refer to this system 2, so that represents this symbolic logic, and system 1, which is the generative AI. Or people say symbolic, it's about logic, and generative AI, it's about creativity. Now, this idea of System 1 and System 2 was made popular by a book published in 2011 by a psychologist, Daniel Kahneman, called Thinking Fast and Slow. So basically, he said that there are two systems of thought. System 1 is fast, is instinctive, emotional. And system 2 is slow, is deliberate, thinks more, is more logical. So what we are saying is that generative AI is like a system 1 type of thinking. So it gives answers very quickly. So if you tried GPT or ChatGPT, you ask a question, and I mean, really, it's quite amazing. It doesn't really take a very long time to get an answer that looks impressive. So that's the kind of system 1 thinking that people refer to. And then we have this symbolic AI, and I hope I've given you a preview of the fact that, in terms of AI, people started with symbolic AI. The attempts were to replicate the human thinking and the reasoning. So this is about deliberate logical reasoning. And you probably heard a lot of, seen it yourself, that GPT doesn't really know how to reason. I mean, it looks as if it's reasoning, but it can be caught quite quickly in showing that it's just not able to reason. And there are other issues there to do with being able to sustain a conversation, right? So being able to have that context of knowledge and being able to respond, in a conversation. So with systems like generative AI and GPT, one of the problems is about the fact that if the conversation is very long, the system gets bogged down. It doesn't know. It just starts, coming up with just nonsense or irrelevant, and it's just contradicting itself, and things are not working. So this is an area where people are trying to solve. So how can we get system 2 type of thinking back into AI? Yes, we can process a lot more data. We have these generative systems that can generate text, summarize text, even images, even videos. But how do we get the system 2 type of thinking back in? So I want now to tell you about some of the research and experiments that I have been involved in. And I don't want to bring all of them because hopefully we have another meeting, but also to just give you 3 different types of systems that I have been involved in that utilizes AI for a narrow type of application, and also reflecting on some of the things I've learned by doing that. So the 3 examples that I chose for you today are an automatic annotation and classification of Malawi legal text. Number 2 is a machine translation, so machine translation for local languages. And then the third is applications of generative AI for self-directed learning. So let me start with the first one. And just telling you about the problem that I was trying to solve. So the problems, this dates back to 2019. So the Malawi legal system is based on case law. This is the English system, legal system. And the laws of Malawi, and by laws of Malawi, I include in here statutes. So this can be legislation passed by parliament. But in addition to that, it can be cases. So cases that have been judged and provide precedent. So that's what is commonly called case law. So these are available to some extent online, but the text is static. So maybe you have a document that's uploaded and it's an image or if you're lucky, it's a PDF, so you can maybe search it. But there is no hyperlinking or linking between different documents. The other challenge is that, or has been at that time, but I think is still the same now, there is a very limited number of commentaries. So things that explain the law and also how the law is applied. Now, for criminal law, no commentaries were available. And the classification of the judgments was rudimentary. So really just maybe classified, categorized per year. So, all the judgment from 2009, all the judgment from 2010, there was, this is a criminal case. So kind of broad classification, type of case, the court that issued it, number of parties. But in terms of making this useful to legal research, you would need one, hyperlinking, so you can navigate between different documents to see how the law was applied, and also more intelligent classification. So brainstorming with one of my legal colleagues, we thought, well, how about we see what AI can do? Can AI help us automatically or semi-automatically annotate entities of interest in the legal text? And this can be basic ones, so references to other cases, references to statutes and laws, but also even finer, classifying judgments based on the legal matter. So, is this is a criminal judgment, but is it theft? Is it homicide? So, trying to look, and even within that, looking to see what the points of law were. And just to make a parenthesis here, that during the brainstorming for this project, one of the judges in Malawi, the judge is retired now, said, well, actually, we need an expert system because there are a lot of people sitting in prisons in Malawi on remand. So, somebody can be in prison for 5 years for a minor offense without their cases ever have been heard. So he said, well, I wish I had something that could say, okay, what are the points related to this case, and help me kind of classify, more quickly what judgment should be passed. Now, just to comment also is there are a few judges in Malawi. Now, I'm not trying to solve here the systematic problems, right? Why are there so few judges and so on? But the immediate solution for us that could utilize AI was to make some sense of these documents faster, or using some kind of automatic means. So we started with that. We said, okay, great, AI can do. So 2019, there was no GPT. So just to maybe mention that as well. So we thought, okay, let's do that. Let's start with a collection of documents. These are criminal cases and laws pertaining to criminal law, and put this data or this knowledge in some database and in some format that then we can run existing AI algorithms to find entities in the text. But we soon realized that, things are not as smooth as they might seem. We also have to do what's called optical character recognition, because a lot of the old cases were just images. So we couldn't really digitize them as easily. So we had to do a lot of data preparation to extract this text out of these files. And then we also had to arrange this text in a structured way. So for that, we used a markup language to help us represent the text. Okay, and sorry. I hope you can. I hope I'm still audible. So after we obtain,
yes, ma'am, you're audible.
Great. After we managed to extract this text in a way that's structured, we had to now do this automatic annotation. And this image gives you an idea of some of the annotations that we wanted to do. So you can see in the middle that we wanted to highlight in all documents references to the law. And then on the left there, you see some keywords. So those keywords were for classification, for legal classification later on. So things like murder, defilement, different offenses, and so on. So the first stage was to extract the annotations in terms of to hyperlink these documents. And then the next stage was to take this even further. So this is now taking us into reasoning. So really the first task, which is about detecting this type of references to laws and other cases, were not really about reasoning. They were more like, system to find those keywords. Right? And systems can be quite good at these things. They're not 100% accurate, but they can pretty much detect most of these elements in the text. And the second level was to go to system 2 type of thinking. So now we want to find a legal classification. So for this, we used an international classification for crimes. So we wanted to take our judgments and say, are they level 1? Are they level 2, 3, and so on? So you can see there that there are, different types of classification. Now, this is a bit harder, and you could take the approach of finding keywords. So for each level, you can say these are the keywords that would be relevant or be indicative that that judgment sits under 1. So that's, a good approach. You can do that. But, even there, you have to do a lot of tweaking for some of the existing systems. But you can't, maybe I hope this, you can't rely only on keywords or textual information. So just the fact that the text is there and you can maybe flag it that, it contains these words, it doesn't really mean that the meaning of the classification, it's really there. So in other words, it's difficult to capture the reasoning required to say this judgment is really on that level, because there are subtleties in meaning. And this is where the machines or the computers struggle with. But we also found that utilizing AI in this way can have really valuable implications to knowledge representation and dissemination, especially in places where there is either no or very little investment in this type of knowledge tasks. Institutions have so many other pressures and probably few resources to put together a really good organized body of knowledge. I think utilizing AI can prove beneficial. So I'm going to go to the next example. So this is machine translation for local languages. So MT there is really machine translation. So I was new to this language. So as I said, I moved to Malawi in 2012. and I didn't speak the language. I took some lessons before I came, just so I can do greetings, but I wasn't able to understand. And it was pretty much becoming obvious that you can't rely on machine translation because they just don't work well on most languages, other than the ones that have, received a lot of attention. But in terms of African languages, that wasn't the case. And there were challenges. So when I started to look at this, other people seem to be interested in that. And in fact, there's been quite a lot of interest in African languages recently and how to develop text or speech tools for languages. So the challenges was in the availability of the data, but also the fact that these languages have a different grammatical structure. And also that it's the phonetics of the language come into play, because the way the language was written was meant to capture the way things are pronounced. But that it's not a perfect match, right? It's not a perfect match in terms of how we pronounce something and how we actually write something. So there was a need to develop good quality data sets and methods and language methods. And computational tools can become very useful in this, because putting together good quality data sets requires some automation. It's difficult to do that manually. And that automation can involve things like document capture. So if it's handwriting, you would think of handwriting recognition, or even just an image, right? We'll have an old document, for example, would have, different challenges in terms of capturing the text in that image. So there would be, a useful application of AI techniques and methods. And I'm just giving some examples of the data sets that I was involved in developing, and some of them were used for different challenges or machine learning challenges for classifying text in local languages. But now the question is, why is language important? And I think language comes in so many domains. And just 3 examples there in Malawi. SMS fraud detection. This is, again, something I've looked at recently. So a lot of SMSs that can potentially be flagged as fraudulent are in local languages or mixed, right? You can have mixed local languages and English. But tools for automatically flagging, or let's say potentially indicating that, this could be fraudulent, be aware, need to take language into account, because, most of the fraud really targets, not all, right? But let's say Malawi, a lot of the fraud targets people who don't speak well English, for example, and they might not have knowledge about how this type of fraud can occur. The other is knowledge access, going to a bank, opening an account, going to the doctor, giving your consent for something requires that you understand the information that's presented to you. So language is extremely important. And, recently, not just I think there's been a lot of development in terms of agriculture, right? Developing or incorporating generative AI in agriculture for knowledge disseminations to the farmers, or maybe knowledge dissemination or knowledge crowdsourcing, right? Getting all those, the useful information from multiple sources. So, but also in medicine or health. So there's been a lot of talk in telemedicine, telemedicine for African languages or in African countries. You have to be able to use local languages in a way that is safe and clear, right? And clear messages. So actually, as I was working on looking at this issue of telemedicine and the use of AI in language, we realized that we need to understand what kind of language barriers take place in facilities in Malawi. So the research I'm showing you, it's only come out, I think, yesterday, if published online, and I'm very proud of it because it's really been a lot of kind of work and close to my heart. So, during this work, we really discovered that there is a gap. There is a language gap, and there is a knowledge gap. I mean, these two are related with each other. To some extent, AI tools can be used properly and in a good way can be very useful. And this brings me to my last example, which is a research that, again, came out from a need that we observed. Apology, I see a spelling misspelled word there. In health. So in Malawi, there is a lot of data that is collected through different systems and tools in terms of the health of the population. I haven't seen a paper that quantifies how much of that data is being collected, and a lot of the data that's collected maybe is used once. Somebody's looked at it. They maybe they use it for decisions purposes or not. So as we were working on a health informatics project, and this was, we were supposed to develop some predictive models based on that health data, I thought, we need to stop, because you can build a predictive model that can give erroneous output because we do not understand how the data is being collected and what is the data showing us. So we decided to look at how the data was collected for that particular scenario, and a lot of that data was it was during COVID-19. So this was COVID-19 data, surveillance data collected Malawi-wide. And a lot of what's called community health workers were involved. So these are, people who do not receive the training at the level of a doctor or a clinician. So they have maybe 6 months training in health, public health type of data. And they are sent out there to collect, different disease surveillance data. And what we discovered is that, these healthcare workers didn't have access to knowledge that they needed to do the work. So they didn't have access to guidance that was relevant. They found difficult to help people because they were going in rural areas. They didn't know the answers to things. They had to go back and maybe come back 2 months later to give back the answers to different questions that were coming from patients. And there was really a gap there. So again, we thought, could we utilize generative AI to develop a tool that gives access to documents, guidance, clinical guidance, and technical guidance that is accessible to health workers on demand, so directed by their needs, they can ask questions over this knowledge base. So we developed a tool. We are still looking at the kind of experiments that we've done with this tool. On the face of it, it looks useful, but these large language model systems that one utilize need to go through a different kind of testing than the typical software. So in conclusion, hopefully through these projects, I give you an idea or encouragement, or let's say evidence that AI can be useful, like macro use of AI integrated with different applications, but it's still experimental. And the gap is in this knowledge, the knowledge representation, which is key to reasoning. So I gave a quote there in terms of the large language models. So LLM stands for large language models. LLMs cannot stop and think. They're just going to give you the text very fast. So, again, does it really reason? So this is where people say, well, it uses only fast thinking, which is system one. And it's really an open question how we can improve, these kind of systems using deliberate thinking, which is system two. But you saw that from the examples I gave, AI was used to automate some of the, let's say, system one type of activities, annotating text, extracting information, trying, even a classification you could think of putting on top of that, finding associations between things. This is in a nutshell a little bit about my journey in AI. So I hand over to questions. Thank you very much for listening.
Hello?
Yes.
मिस कर दिया So do we have any questions? I request everyone present in the audience to post their questions in the chat box.
Dr. Janvi, if they have not posted any questions, you can allow them. If they can unmute and ask, if they want to, you can do it.
Right, sir.
Anybody having some query may directly ask, unmute and may go ahead asking the question. Mr. Jay wants to ask.
Yes, sir. With your permission, I would like to ask just one question to the ma'am. That in Malawi University, is the library using any AI-enabled service or AI-enabled search engine?
Dr. Amelia, he is our librarian. His interest is asking a very relevant question. I mean, is your library using any AI-based solution? That's his question.
Okay. So maybe if you can mute, I think it's the background noise. Yeah. Okay. Thank you. That's great. So we have subscribed recently. We have started to engage with the library at the university. So I don't think the national libraries utilize anything that uses AI. But at the university here, we've recently had an initiative where we want to use AI to navigate multiple documents and also, relate or build a knowledge, let's say, a search tools on top of that. But this is not something that has progressed beyond the initial stage. So there are some text-based tools that can be used. And yeah, that's what we've done recently. We looked at that. So, for example, the library has some old newspapers. So one of the problem is space, right? So there's a lot of information there, and a lot of like archives that need to be digitized, but then they need to be digitized and have some ways of searching for the information and relating information. So yeah, these are the idea stage at the moment.
Professor, thank you so much. We have a couple of questions in the chat box also that I'll read, and then you can answer accordingly. So there's a question by one of our students, Vinith. Can you speak to the opportunities of AI that creates, especially for today's students and young professionals?
Okay, let me look. Can you repeat that? Is it in the chat?
Yes, ma'am. The question is, can you please talk about the opportunities in AI, especially for young students and professionals?
Okay.
Dr. Amelia, actually, what students is wanting, one, the beginning statement is very important. This is related to threat. Many people fear that AI will replace the jobs. Can you speak to the opportunities AI can create, especially for today's students and young professionals? What advice would you give to someone wanting to enter the AI field today? Are there any specific skills or areas of study where you recommend they should prioritize? That is the question. So it's, I think, basically related to the threats of AI. So you would like to answer?
Yeah. Yes. Well, I mean, some people say, I mean, that AI will have an impact, a positive impact in terms of demographics. And let me explain. So some countries are, for example, concerned with not being able to have younger people or the workforce might be depleted because of demographics, and AI can then or AI type of systems will then can be developed to fill that gap. Now the other impact on jobs is this idea that AI can have an implication on deglobalization. So what's happening here? We are talking about a globalization effect where, if you don't have you can basically increase productivity in your country without having to appeal to maybe resources somewhere else, because you'll be able to automate and have AI do some of these tasks, right? But now, these AI systems, as I was trying to say, so a lot of, the more complex an AI system is, the more the knowledge aspect becomes very important. So customizing and developing these tools require a specialist workforce, right? And I was giving an example there in terms of expert systems. So a lot of expert systems have been abandoned because the maintenance effort in terms of the knowledge was just too demanding or maybe too expensive. So maybe to give you then an idea here is that, of course, you need practical skills, which can be, IT type of skills, but the kind of skills that are even more kind of high level and essential would be things to do with knowledge and reasoning, because this is where the gap is. You see, if you want to develop a generative AI system, your options are basically use existing large language models, but you have to pay for them, right? So, access to computation in countries that, have poorer resources, or let's say you're a library and in Malawi and you want to apply some AI because it speeds your work. Well, that's a custom solution that needs to be developed. So the skills to do that can be multiple type of skills. So I think in terms of your question, it depends, where you want to be looking at. I mean, you can be a person who understands how to plug in components, right? And how to integrate, because like the example I gave you with the legal documents, you don't just need something to process the document. You need a pipeline. You need something that goes from A to Z, right? And which is able to integrate this AI. And that's where a lot of problems are, integrating this type of technology into another system and, having like a full circle, data flow circle. So in terms of division of work, I mean, you can think that you need a system architect, somebody who understands how these components can be put together in an optimal way, because you're talking about flow of data. Knowledge engineering, somebody who understands, how to, because we are still doing requirements, right? We still have to translate the real world knowledge into something the machines can actually process. So that's a skill in itself. So to answer to your question, I think maybe some automatic jobs will suffer, right? Because we can do something faster. But most of this automatic task would be about a reshifting of the skills that the person does. So maybe the person will not spend time in annotating, but the person will spend time in checking the accuracy and in preparing the data. I hope that answered the questions.
Yes, absolutely. Thank you. I think you can read one question, Dr. Janvi of Sindhura. It's a good question.
Yes, ma'am. So, Dr. Sindhura Gudupati has asked, how can natural language processing techniques be adapted to accurately process, analyze, and interpret classical Sanskrit text, given the unique grammatical structure, rich morphology, syntaxical complexity of the language?
Dr. Amelia, Sanskrit is very ancient language of India. So her question is related to Sanskrit language.
I mean, this is a really good question, and I can't answer it because I don't know. Maybe just so again, it's a lot of tricky bits in there, right? So let's say you have maybe the best way to give is an example. Because you're touching in using AI for, let's say, old text, but maybe still spoken. Also in terms of archaeology, right? So actually people have used AI to decipher the meaning of ancient inscriptions or ancient text. And but all those systems are semi-automatic, right? So there's a lot of experimentation that will go into that. So I wouldn't necessarily know. I can't give you like a full answer that, you should do this and that. But I would say that's a substantial type of project, and you'll have different aspects. One, you will approximate, right? You will take the Sanskrit text into the computer. So this is where you have things like fonts, for example. How do you represent text that's in an image faithfully? That this represents that. So it's all a mapping. It's all about mapping, the data with something the computer's processes. And, you need a human to do that. I mean, computers can't do that at the moment. And also in terms of matching the meaning of the text. And I think I was mentioning there is phonetics. So there's a lot of work there, how to capture sound, how to capture voice, and then do speech to text, for example. So I don't know in terms of the Sanskrit, where has there been any work on that? What's the progress? So first you would need a data set. So you would need to spend time in developing and putting together a data set that you'll be utilizing. And then you will have to understand the task that you are trying to accomplish, with that text. What's the end result? And then build your components from there.
Thank you, ma'am. So we have one more question by Dr. Priya Goel. What are the current limitations of AI system compared to human intelligence?
Well, it's the reasoning aspect. So computers are very good at, putting text together. I mean, the person who asked the question, I don't know if they've used GPT or GPT-4.
I'm sure everyone is using, ma'am, right now.
Yeah, so you see, the interesting thing that is happening at the moment is, GPT answers really fast. I mean, there's almost no time for thinking. It just tells you. And, and not only that, but GPT has access to vast amount of, I think somebody was saying, well, it captures everything that's available on the internet, plus books, plus other things, right? But somebody was saying even that doesn't come close to how much information humans capture, because the information, even a child, I think somebody did some studies in terms of the amount of information that we take in, during our life, right? And that information is not just text. You can't capture everything in a text or even in an image. So at the moment, the reasoning is really a problem. And the interesting thing is that people notice that when they know an answer to a question that they ask GPT, they find issues. So they realize that, so basically, if you ask a question in your own domain, you spot mistakes. You say, no, this is not accurate. But when you ask GPT a question that you don't know anything about, or it's not your domain, you're impressed. You say, "Oh, wow, this answer is really wonderful," right? So this is a known issue that, the data is there. We have big data. We have a lot, but the reasoning and also having a contextual reasoning, that's the other thing. That you are sustaining reasoning over different, like I talk to you now, we are talking to each other. We've just had the, kind of talk for the last hour, but you are able to follow, whereas a language model cannot follow. After some time, it just loses it.
So thank you so much, ma'am. Now we have reached to the end of this session. So on behalf of GSFC University and everyone present here, I would like to extend once again our heartfelt gratitude to Professor Taylor for taking time for us and adjusting to the time difference in India and Malawi also. And thank you, Professor Amelia, for taking us through the fascinating world of AI, right from its embryonic stage to the current advanced stage. So thank you so much. And we also appreciate that you have shared the experiences of yours in terms of legal challenges and research you have faced in Malawi. So thank you so much for this informative session.